Hi, this is Chantel, and I'm talking about Quiz 4 from College Algebra at CCV in Winooski over the summer of 2019. All right, so the first problem we're being asked to solve for A. And as you can see in the problem here, A is in the bottom, and it's part of an expression. It's not just by itself. So anytime we have a fraction equation and we're trying to solve for something, we want to get rid of the fraction. It's the easiest way to deal with things, but we have to get rid of it if the variable is in the denominator. We need it in the top. So we have two different expressions here, a plus 2 and a plus 4. And so the only common denominator that we can have is the two of them multiplied together. So we need to multiply both sides by a plus 2 times a plus 4. Both sides need to be multiplied by that. So I'm going to kind of write over here to the side, a plus 2 times a plus 4, and that's going to be times basically the whole expression. And then this one is going to also be a plus 2 and a plus 4. Okay, so now we want to look at what divides out on each side of the equation. So on the left side, I see a plus 2 is going to divide out. And on the right side, a plus 4. If you don't get rid of all of your denominators, you've done something wrong. So on the left now, we're left with 5 times a plus 4. And on the right, we're left with 4 times a plus 2. And now we just need to distribute, get a by itself, and solve for a. All right, so we've got 5a plus 20 equals 4a plus 8. Now I'm going to subtract 4a from both sides. That means I'm going to bring my a over to the left, and I get a plus 20 equals 8. Divided out, or I subtracted out right there. Now I'm going to subtract 20 from both sides. I did not mean to draw that line right there. So I'm going to redo that. I'm going to say minus 20 minus 20. Okay, so the 20s subtract out, and I'm left with a equals negative 12. Okay, so a is negative 12. The next problem asks us to solve for x. Pretty much all of these problems are solving for a variable. And when you have a radical in the equation, you want to get the radical by itself as best you can, unless there's 2, and that's going to be the next problem. But this one, we're going to get it by itself. So we want to say minus 3 on both sides. And I end up with the radical alone, x squared, plus 6x equals 4. Now the reason we wanted to do that is so that we can square both sides to make the square root go away. So they're inverses of each other, which means they cancel each other out, and I get x squared plus 6x equals, and 4 squared is 16. Now if I bring the 16 to the other side, I'm going to have a trinomial which I can then factor. So I have x squared plus 6x, and I'm subtracting 16 from both sides, so that I end up with minus 16 equals 0. Okay, so now I see that this is a factorable kind of trinomial, and you might want to play with it first to see, or I guess you could use the quadratic or something like that, or complete the square if you want to get complicated, but this is factorable. So I need two things that multiply together to give me a negative, so I'm going to have a plus and a minus. And if you play around with it a little bit, you will find that x plus 8 and x minus 2 give you a positive 6 in the middle. So when I multiply them, I get minus 16. When I add them together, I get plus 8 and minus 2. That is a positive 6. So then I set these each equal to x plus 8 is equal to 0, and you set x minus 2 equal to 0. And the reason for that, in case you're wondering, is that each of these two, because these are multiplied together, one or the other one needs to equal 0, and in the case of these kind of problems, they both are equal to 0 at one place or another on the graph. All right, so once we've done that, we can rearrange and say minus 8 on both sides so that x equals negative 8. And on this one, we say plus 2 on both sides, and x equals 2. So we get two answers of negative 8 and positive 2. Okay, the next problem, we will have to square it two different times. So the first time we square it, we're going to see that one of them goes away, but we don't get rid of the other one. So in this case, we get square root of a minus 4 squared is just a minus 4. And then on the right side, we're going to have, this is just basically two terms. We've got one term here, and we've got one term here. So we're squaring it, which means we're going to square the first term. So we're going to have, I'll write the whole thing out, a plus 8, and that is squared. And then we're going to have 2 times 2 times the square root of a plus 8. And this is just squaring a binomial, and if you don't remember that, you might want to go back and look at the review chapter. And then we're going to square the last term, so we get plus 4. Okay, so we get a minus 4 equals a plus 8, because the square root and square cancel each other out, minus 4 times the square root of a plus 8 plus 4. All right, so now we're going to bring everything to the same side together and have the radical by itself. So I'm going to bring this to the left, this to the left, and this to the left. So I'm going to subtract all of those things, and I get a minus, so I subtract that there, and I get the a's actually go away. And I have minus 4 plus 8 plus 4, minus 4, sorry, minus 4 minus 8 minus 4. So I'm going to end up with negative 16 on the left side, minus 4 minus 8 minus 4. I was running out of room and I was getting lazy, but writing it down is probably a better idea. All right, and that is going to equal negative square root of a plus 8. And there was a 4 in there too. All right, so we've got negative 16 equals negative 4 square root of a plus 8. So I'm going to divide both sides by negative 4. And they divide out here. And here I get the negatives are going to divide out. And 16 over 4 is just 4. So now I'm going to rewrite that mess. And I get 4 equals the square root of a plus 8. All right, so this is where we have to do it again. So we have 4 squared, square root of a plus 8 squared. So I have to square both sides to get rid of that radical. And I get 16 equals a plus 8. I'm going to subtract 8 from both sides, and I get a equals 8. Okay, so that's our final answer on that one. A equals 8. And I really recommend that you go in and I'm not going to show you for the sake of time, but go in and check 8 and make sure you really do get a true statement there. And you will get a true statement. Okay, so for the next 3 questions, we're supposed to solve the inequality and answer in interval notation. So the first thing I'm going to do is I do want the x terms on the left. They just make more sense. It's not necessary if you can figure it out, but it just makes more sense with the way we write the less than or greater than symbols. So I'm going to subtract 4x from both sides, and I get negative 3x plus 3 is greater than 6. Now I'm going to subtract 3 from both sides, and I get negative 3x is greater than 3. And now I'm going to divide both sides by negative 3. And when I divide by a negative, I have to switch the sign. So now I'm going to get x is less than 3 divided by negative 3 is negative 1. Okay, so x is less than negative 1. And then what you want to do is put this in interval notation. And so it's going to be everything from negative 1, not including negative 1, to the left this way. Okay, so we want to write it from negative infinity up to negative 1, but not including negative 1. So that's what the interval notation looks like. If you don't know how to do that, you might want to look back at review section 1, the very first section in the book. Okay, the next problem is similar, and we're going to solve for the inequality. first thing you want to do on these is always get rid of the fraction. So I have a 1/2 in front of this whole thing here. So I'm going to multiply both sides by 2, or you can think of it as 2 over 1. And I'm going to multiply the other side by 2. And so the fraction goes away, and I end up with x plus 3 is less than or equal to, you want to distribute that to 2x minus 6. Now I'm going to subtract both sides by 2x, or to subtract 2x from both sides, and I get negative x plus 3 is less than or equal to negative 6. Now I'm going to subtract 3 from both sides. I get negative x is less than or equal to negative 9. Now I need to divide both sides by negative 1 or multiply by negative 1, however you want to think of it. And when you do that, you need to switch the sign. Okay, so that is going to become x is greater than or equal to 9. Okay, and what that looks like is everything from 9 to the right. So it's going to be, if this is our line, we had 9, it's going to include 9, and it's going to go to the right like that. And that is going to be, we're including 9 up to infinity, and it never includes infinity. So the interval notation looks like that. Okay, the next one is more of a compound inequality. We've got the x is sandwiched in between two symbols, but it's really no different. What we want to do is we want to subtract 4 from all parts of this. And I get negative 1 minus 4 is negative 5. Is less than or equal to, the 4 went away, negative x is less than or equal to negative 1. All right, so now I want to divide everything by negative 1 or multiply everything by negative 1. It doesn't matter. Whichever way you want to think of it is fine. And the negatives all go away and the signs all switch. So I get 5 is greater than x, greater than or equal to, is greater than or equal to 1. Now the best way to write this then is to say, well, 1 is actually less than or equal to x is less than or equal to 5. It doesn't make sense the other way. We should always think of it from left to right, because that's the direction the number line goes, and it's also the direction the interval notation always goes. So we're going to say this one goes from 1, including 1, up to 5, including 5. Okay, the next one is an absolute value equality. So all we're trying to do is solve for x, and remember that x can be two different things now because of the absolute value. What's inside there could be a positive or it could be a negative. So we've got x minus 1, and we want to subtract 5 from both sides. So we say minus 5, and we get equals 4. So what that means is that x minus 1, the quantity inside there, could either have been a 4, or x minus 1 could have been a negative 4. So there's no way to know which one it is. We just know that it's either 4 or negative 4 in there. So we have to say both of them. So we're going to add 1 to both sides of this one, and we get x equals 5. And we're going to add 1 to both sides of this one, and we get x equals negative 3. So our answer is going to be negative 3 and 5. For the last 3 problems, we're going to solve an inequality, write it in interval notation, and then graph it. So there's a lot of things going on here. The first one, we've got just an x is less than or equal to negative 1. We don't have to solve that. It's already solved. So all you have to do is say, well, it goes from negative infinity up to negative 1. It never includes infinity on either end, but in this case, it does include 1. So that looks like a solid line on the negative 1. And we're going to, sorry, I had solid dot, and then we're going to make I was anticipating my very bad line that I was going to be drawing, distracting myself. So you have a solid dot on negative 1 and a line going, an arrow going to the left all the way to negative infinity. All right, this next question or problem is from the absolute value inequalities section. And in your notes, we laid out how to think about each of these. So if you're confused, go back and look at that. But what this is saying right here is that there's some number, x minus 6, that is at a distance greater than 5 from the origin. So I've drawn a little number line up here. This is a distance of 5. This is a distance of 5. So there's some number, x minus 6, that's either out here, right? Or it's out here, or both. Okay, there's some x that we can come up with that will make either one of those true. So what we need to do is say, well, okay, x minus 6 then must be, I'll do it in red here, this one here. right? X minus 6 must be that one. So it's going to be less than negative 5. And the other one I'll do it in green. And we've got this other one where x minus 6 could be greater than, or I should say, or equal to positive 5. Okay, so it's or equal to, I'll fix that. So that's where the two x minus 6's lie. And now we need to figure out what x is, not what x minus 6 is. So now I'm going to say x plus 6 on both sides. So plus 6 plus 6. So x is less than or equal to negative 5 plus 6 is 1. Or I'm going to add 6 to both of these. And I get x is greater than or equal to 11. Okay, so we end up with less than or equal to 1. So that's this part right here. And we've got a solid dot because it's less than or equal to. And the other one is 11. So any number that I put in there is going to make this true. And again, I really recommend that you always check. So pick a number, pick an easy number. For this one, you could pick 0 and stick it in. 0 minus 6, absolute value is 6. That's greater than or equal to 5. That's true. 11 or 12 over here on the other end, minus 6, absolute value. That is greater than 5. So check something in between and make sure it's not true. So that's how you check absolute value inequalities. This is pick in different parts, check them, and see if they're true or not true. Okay, so now the interval notation is going to be a little complicated because we have this section over here, and this section here is going to be negative infinity to 1, and it does include 1, and that's going to be union with this other side over here. Normally you're going to write this all together, but I'm just trying to correlate it to the picture. This one starts at 11 and includes it and goes up to infinity, but does not include infinity. So the answer is this whole thing right here. All right, this next one is a similar but different problem. First thing you've got to do is get the absolute value by itself. So I'm going to add 2 to both sides, and I end up with 3x minus 6. Absolute value is less than 3. All right, so just similar to what we were saying before, we've got something, 3x minus 6, some value that is at a distance of 3 from the origin. So that could be to the negative side or to the positive side, but we just know that the distance is 3, okay? So, but this time it's less than 3. So that means that 3x minus 6 can fall in here, or it can fall right in here, okay? So once again, I should have done this in colors, but we'll call that the green one, and I'll do this one as the red one. Okay, so really what we have here is that 3x minus 6 is anywhere in here, anywhere in there between negative 3 and positive 3. So I'm not going to need my colors because look at that. They're all together in one big section between negative 3 and positive 3. And the way we write that as a compound inequality, we say, well, negative 3 is at the left end, and that is less than 3x plus 6, or minus 6. And that is less than 3. So that's telling us that 3x minus 6 is between negative 3 and 3. All right, if you don't understand any of that, back up and look at it again. Go back and look at your book. And we're going to add 6 to both sides. And this is just what we did before. And we get 3 is, sorry, negative 3. Nope, we get positive 3 there. Is less than 3x is less than 9. And then we're going to divide everything by 3. And I end up, I'll have to come over here, I end up with 1 is less than x, because the 3's divide out, is less than 9 divided by 3 is 3. So now x must be between 1 and 3. It does not include 1 and 3, so I need to put open circles. So 1 is here, and 3 is here, and x falls somewhere, anywhere in here, in between, but not including 1 and 3. And the way we're going to write that is from 1 to 3, but not including either 1 or 3. And that's the final answer on your interval notation. All right, thank you for watching.